Hello, my wonderful viewers. Welcome once again to this online class. In today's class, we want to continue from where we stopped. In our previous class, we looked at how we can convert numbers to base 10. But in today's class, we are going to look at how we can convert numbers in base 10 to other bases. So last class, we looked at how we can convert numbers in other bases to base 10. So this time around, it's going to be vice versa. So we have an example on the board. The question is express 980 base 10 in octa. So that means we are going to convert this to octa, and also we are going to convert it to hexadecimal. So it's still the same number, 980 base 10. So we convert it to octa and we also convert it to hexadecimal. So the first one, converting it to octa. Octa number system simply means base 8. So that means we are converting 980 base 10 to base 8. Okay, so the first thing we are going to do, 8 in 9, that is 1, remainder 1. So put the 1 here. So that's going to be 8 in 18. 8 in 18 is 2, remainder 2. And also, so we have 20 here. 8 in 20, that is 2, remainder 4. Because 8 in 20, so 8 times 2 is 16, so that's remainder 4. Okay, another 8. So 8 in 12, 8 in 12 is 1, remainder 4. So that's 42. 8 in 42, that is 5, remainder 2. Because 8 times 5 is 40, so we have 42, so that means we have remainder 2. Okay, 8 in 15, that is 1, remainder 7. And 8 in 1 is 0, so you just take the 1 here as your remainder. Now, that simply means 980 base 10 is equals to 1724. 1724 base 8. So that's our answer. Moving on to example 2. So in example 2, we are asked to express 980 base 10 in hexadecimal. So talking about hexadecimal in number base system, it simply means we should express 980 base 10 to base 16. Hexadecimal means base 16. So we are going to do that now. 16 in 98, that is going to give us 6, remainder 2. Because 16 multiplied by 6 will give us 96. So that means there is going to be remainder of 2. So when you put the 2 here, that's 20. So 16 in 20, that is going to be 1, remainder 4. So it's going to be remainder 4. Okay, 16 in 20, 1, remainder 4. Alright, moving on to the next one. 16 in 61. So talking about 16 in 61, okay, when we say 16 times 4, 16 times 4 is going to give us what? 6 times 4, 24. We have 2s for here. That's okay. That's too much. What about 16 times 3? 16 times 3 will give us 48. Will give us 48. So that means 16 in 61 will give us what? It will give us 3. Now, but the remainder is going to be 13. Because when you say, okay, 3 plus this, 1, 6. So the remainder is 13. 16 in 61, 3. Remainder 13. Now, I can't write 13 here. I cannot write 13. All the remainder must be what? A single digit. But if I write 13, that's double now. So I'm going to apply hexadecimal numbers. In hexadecimal, hexadecimal starts from this. Hexadecimal number involves 0 to 15. Because hexadecimal is base 16. So that means you cannot write 16. So the number involves 0, 1, 2, 3 to 15. But in decimal involves 0 to 9. Anything above this, you cannot have 10 in decimal. You can only have 1 0. You cannot have 11. You can only have 1 1. So in that case, your 10 is A, your 11 is B, your 12 is C, your 13 is D, your 14 is E, your 15 is F. So that simply means A is 10, B is 11, C is what? 12, and D is what? 13. Now our remainder 13 here, instead of writing 13, we are now going to write D. Now the next thing, 16 in 3. So that will be 0. Because 16 cannot go in 3, so we are going to write 0, and you will bring your remainder down. So this simply means 980 base 10 is equals to, start from the bottom, 3d4 base 16. So this is going to be our final answer.